So this is the code that you need to write to calculate this interest for 20 years and 80 quarters. So as you see, earlier I had 4 lines to calculate the interest of 4 different quarters. But the moment I use or introduce loop in this code, those 4 lines have reduced to just 1 line. In case if you are not implementing loops, then those 4 lines will multiply by 20 and that will become 80 lines. So as I told you earlier, a good SAS program shouldn't have these many number. So if you can achieve your task in less number of lines, you should try to minimize the number of lines implemented in a code, and that way you can save your resources. So if you see, instead of writing 20 lines to calculate interest for 20 years and instead of writing 80 lines to calculate interest for 80 quarters, I have just converted into a loop demo where I'm just writing 1 line here to calculate the yearly interest for 20 years, and this second loop which is calculating the quarterly interest for 80 quarters, and I'm getting the output for 20 years and 80 quarters. And these are my yearly and the quarterly earnings, and you can compare where the earning is more and accordingly go for that particular mode of interest. And if you see this year index and the quarterly index that I have used, the quarter index that I have used, this is one more than the stop value of the loop. If you are printing only the last value of your loop, then the index is always one more than the stop value of the loop. But if you are instructing loop to write every calculated value, in that case it is going to print correctly those 20 years and 80 quarters. So we have an option, we have a keyword called as output, by which we can print every observation which is computed, even the intermediate results. For example, what was the interest at the end of year 1, what was the interest at the end of year 2, at the end of year 3, year 4, and so on. So I just need to say output here and output here. And in this case it is going to print those 20 years and 80 quarters. So now if you execute this code once again, now if you see, my output data set has 100 observations and 6 variables. So if I proc print, so as you see, the first 20 observations must be representing the yearly earning, the yearly interest. And just see, when it is writing yearly interest, that time the quarter values are missing. Quarterly interests are 0. As we discussed many times earlier, when you create a variable using sum statement, the variable is assigned a value 0 initially. So as you see, this is the interest at the end of year 1, this is year 2, year 3, year 4, year 5, year 6, and so on. Like this, it has printed 20 observations for 20 years. Then you have this observation which is representing 21st year, which is actually, so this is the interest earned in 20th year, and this is quarter 1. Now you should focus on the quarterly interest. From 21 to 100, that is for 80 quarters, you will see the same interest repeated or written to all the observations till end. So this is the interest earned at the end of quarter 1, this is quarter 2, quarter 3, quarter 4, and so on. So like this, if you just scroll till 100, observation number 21 to 100, that is in 80 observations it has written the quarterly interest. So this is the advantage of making use of loop, and you can reduce your code drastically. Okay, let's see the next assignment. So our next question is, each year starting 2011 an employee invests $5,000 in an account. We need to determine the value of the account after 4 years based on a constant annual interest rate of 8%. So this person is investing $5,000 every year for 4 years, and this is the rate of interest that he is getting. We have to find out the amount that he is going to get at the end of 4th year. So let's write the code for this. Before that, we'll clear the output window, the log window. So we'll try to get the solution for this code again using loops. There is no input data set involved even in this case. So I say data calculate int, and then I say capital plus 5,000, then I say do year is equal to 2008 to 2012 capital plus capital into 0.08, then I say end. Let me take this also inside my loop. So do year is equal to 2008 to 2012 capital plus 5,000 capital plus capital into 0.08. I say run. I execute this code. We need to write a semicolon here. So missing semicolon is a common error which programmers make. Okay, so if you see now, it's writing one observation and two variables to my output data set. I say proc print data is equal to calculate int, and then I say run. This is my output. So as you see, this is the output that I'm getting. So at the end of 4th year, I'm going to get 31,679 as my capital amount. As you see, again we are printing the last value. So the index variable is printed as 2013, which is beyond the stop value of our loop. It is one more than the stop value of our loop. So let's try printing every calculated result so that the year values are written correctly. So I just say an output here. Now if you see, it is writing 5 observations. This range that we have written 2008 to 2012 is actually 5 years, 8, 9, 10, 11, 12. We were asked to calculate this for 4 years, so we'll reduce this loop range and make it only 4 years. So we'll say do year is equal to 2008 to 2011. So 2008 to 11 will make it 4 years. You can write 2000 instead of 2008, you can write 1 to 4 also. But when this year is printed in my output, instead of writing the year value as 1 to 4, that is 1, 2, 3, 4, if we write 2008 to 2011, that is 8, 9, 10, 11, this will make more sense. That's the reason why I selected the loop start value as 2008. So person started investing in 2008 and stopped in 2011. So this makes 4 years. So now the amount earned would be a little less because the earlier amount shown was for 5 years. Now this is for 4 years, and we are ensuring that every calculated output, observation or intermediate result is written to my output window. So now it's writing 4 observations to our output data set. Let's proc print it and see. So if you see, this was the interest earned at the end of year 1, this was the interest earned at the end of year 2, this was the interest earned at the end of year 3, and this was the interest earned at the end of year 4. So when you are writing every calculated result, in that case that index will not go beyond the stop value. So index is correctly written as 2011. So this is the solution for question number 12. Now let's discuss the solution of question number 13. So question number 13 says, write a SAS program to create a forecasting application to compute number of employees in each of the department of a Randstad after 10 years. And we need to use an input data set for this, which is growth. So let's see what information we have in this growth data set, and let's create this forecasting application to compute or to calculate or predict the number of people in each of these departments at the end of 10th year, or let's say from year 1 to 10. So I clear my output, I clear my log, go to my editor and type this proc print. I say proc print data is equal to Orion dot growth. Then I say run. So if you see, these are my departments. So we have administration, engineering, IS, marketing, sales management, and these are the number of people in each of our department. So we have 34 people in administration, we have 9 people in engineering, we have 25 in IS, we have 20 in marketing, we have 201 in sales, 11 in sales management, and so on. And this is the rate of increase given. So in administration, 25% people are getting added at the end of every year. In engineering, 30% people are getting added at the end of every year. 10% people are getting added in IS, 20% in marketing, 30% in sales, and 10% in sales management. So these are the current number of employees, and this is the rate of increase by which employees are getting added in each of these departments. So we have been asked to compute the number of employees that would be at the end of year 1 in administration, engineering, IS, marketing, sales, sales management, then year 2, year 3, year 4, year 5 till year 10. So we'll try to achieve this using loops to avoid multiplying a number of lines. So I say data, and then say forecast, then I say set run dot growth, then I say do year is equal to 1 to 10, then I say total underscore employees is equal to total underscore employees. So total underscore employees is equal to total underscore employees into 1 plus increase. Total underscore employees is equal to total underscore employees into 1 plus increase. Then I say end, run, and since this is needed for every year, as of now if I execute, this is going to print the number of employees at the end of 10th year. To have it for every year, you need to write output just before this end statement. So let's see. So I say total underscore employees is equal to total underscore employees. You need to also say total underscore employees plus total underscore employees is equal to total underscore employees plus I don't think this is needed. We can just say total underscore employees into 1 plus increase. So when you expand this bracket, this will be like total underscore employees plus total underscore employees into increase. So just say total underscore employees is equal to total underscore employees into 1 plus increase. Now I say proc print data is equal to, we say forecast and run. So if you see, this would be the number of people in every department at the end of 10th year. Now again, if you see, since we are printing the lastly calculated result, everywhere the year values are written as 11. But actually these are the numbers calculated at the end of 10th year. So we'll just go to our data step and write an output to print the number of employees calculated at the end of every year. So now since we have 6 departments, so for each department we want this number to be written for every year. So we'll get around 60 observations in our output data set. Okay, so this is what we are getting as our output. So for administration we are getting for 10 years, as you see. If you remember, this was earlier, this was the result that was printed, but this was shown as year 11. But as you see, this is actually the number calculated at the end of year 10. So I'm getting 316.65 number of people at the end of year 10 for administration. Similarly, you see some number calculated at the end of every year till 10 years. This is for engineering, this is for IS, then you have for marketing, sales and sales management. Now if you see this number of employees is written with decimal digits. In case if you want to round off this, you can use round function here. So you just pass everything calculated as a parameter to round function, and round function is going to round off these numbers to the nearest integer. So clear the output, log window, execute this, proc print it. So if you see, now it has rounded off to the nearest integer. So for admin, this is what I'm getting. Okay, 325. At the end of 10th year in administration, there will be 325 people. Engineering, at the end of 10th year, there will be 131 people. IS, at the end of 10th year, there will be 67 people, and so on. So we have rounded off the number to the nearest integer. So you can pass that entire calculated result as a parameter to round, and round will round off that number. So this is the solution for question number 14. Let's see the next question. Sorry, that was the solution for question number 13. Now let's see the next question. So next question is, consider the investment of the employee in question number 12. So question number 12, employee was investing in every year starting 2011. Okay, so he was investing every year starting year 2011, and this was his investment. Determine the value of the account after 4 years based on a constant annual interest rate of 8%. Okay, so question number 14 says, consider the investment of the employee in question number 12. Stop the loop if 25 years is reached or more than 2,50,000 is accumulated in the account. Okay, so now let's see how to create the solution for this task. So this earlier demo that we implemented, where the employee was investing, where the person was investing 5,000 in every year, and he invested for 4 years, when we calculated the interest at the end of 4th year, and then we printed all 4 years interest. This was starting 2011, so we started 2008, so you can make it 11. So if it is 4 years, it will be 11, 12, 13 and 14. So this was the format of my program earlier. So if you write 2011 to 14, it is going to print 11, 12, 13, 14. So we have to consider the same investment, but we have to stop this the moment 25 years is reached, or in that particular account 2,50,000 is accumulated. So in this particular case, we need to combine the iterative looping with conditional looping. Iterative looping is where they said we have to compute it for 25 years, and conditional looping is because we have to stop the moment that amount is reached 2,50,000. So let's write the code for this. So I say data cal int, let's calculate interest. Then I say do year is equal to 1 to do year is equal to 1 to 25. This is iterative looping. We have to club iterative and conditional looping. While capital is less than or equal to 2,50,000. So do year is equal to 1 to 25 while capital is less than or equal to 2,50,000. Then we say capital plus 5,000, and then I say capital plus capital into 0.08. Then we say end and run. So when I execute this code, and proc print this, this is what I'm getting. So if you see, the year value printed is 22,000. The year value printed is 22, and the capital, the amount calculated in that particular year is 2,72,000. So if you see, in this case, this criteria has become false and the loop has stopped, meaning the capital exceeded 2,50,000 and my loop stopped, but the year was not reached to 25. Now if you print every calculated result just to cross check the output, that what was the capital computed in year 21. So I say output, clear this, so if you see, in year not 21 but in year 20, the amount calculated was 2,47,000. That initiated the next iteration, and in next iteration in 21st year the amount exceeded 2,50,000. So the criteria became false and the loop stopped, but the year was not reached 25. I can do the same task using another conditional looping keyword called as until. Difference between while and until, as you saw, while printed the year value as 22, but actually this amount 2,72,000 was calculated in 21st year. This until is going to correctly print the year value, because in while, every time when loop starts, the index variable is incremented and then the condition is checked. Whereas until is exactly opposite of it, where condition is checked first and then the loop is incremented. So while checking the condition in 21st year, when it finds that this capital has exceeded 2,50,000, it will never go to the next loop and increment the index variable. So here we are going to get the year value as 21. So if you proc print, as you see, the year value is 21 and the same amount 2,72,000, which along with while printed. When I even see here in this case, I'm writing an output, and that's the reason why the output of while and until is same. When I was writing the lastly created observation using while, it was printing the year as 22. Now see what is the value printed when you are using, calculating that number of years using until. So I clear this. When you are printing every calculated observation, then there is no difference. But if you are printing only the last observation, until will print the year as 21 and while will print the year as 22, because until check the condition and stop, whereas while incremented the loop and then check the condition, and it was too late to roll back and get the previous year value. So it printed the year as 22. So this was the solution for question number 14. Now let's see the last question and we are done with this current topic. So current questions, the question number 15 says, write a program to create a new data set and create an array to store all quarterly donations and rewrite it in a new data set with 5% increment. So we have to assign all the quarterly donations to an array and then increment all those amounts by 5% and write it to the output data set. So let's see. So we have to use the same data set that we used earlier. Orion dot employee underscore donations. So here we have those quarterly donations, quarter 1 to quarter 4. So let's write the code to get this output. So I say data increment contributions. I say set Orion dot employee underscore donations. It's not case sensitive, you can write it in any case. And then I say array contrib dimension 4 referring to quarter 1 to quarter 4. And then I say do qtr is equal to 1 to 4 we say do qtr is equal to 1 to 4 contrib of I is equal to contrib of I into 1.05. This is going to give me this contribs or quarter values incremented by 5%. Then I say end, I say run, and I compile my code. So there's some error, array subscript out of range. You can see here instead of quarter I need to say I, because I'm using the subscript variable as I. Or you can say contrib of quarter. So with earlier form, if you want to go, this is how it would be. I consider the subscript value as, the index variable as I. So here we computed 5% incremented contribution for every employee. Now if I say proc print data is equal to Orion sorry, I say inc contrib and run. Here we have, let me print, I say var employee ID quarter 1 to quarter 4. So this is not going to print the unwanted variables in your output window. So if you see, this is what we computed. So if you see, this amount was 25. We calculated 5% of 25, added to it, and this is 26.25. This was 15 everywhere earlier. We computed 5% of 15, which was 0.75, added to this, and the amount written is 15.75. So this is how you need to get the solution for this task using arrays and loops. So with this, we completed this assignment, which had around 15 questions. So we discussed so far 3 assignments. Our first assignment had 10 questions, second had 10 questions, and third had 15 questions. We discussed so far around 35 questions based on the discussions that we had so far. Hope this is going to help you, not just writing code, seeing a business scenario, but also how to debug that particular code. So we'll start the next topic soon, which is macros and SQL. Thank you.